Okay students, now theorem number 10.3. Here we have to prove that perpendicular drawn from center of a circle to chord bisect the chord. Perpendicular drawn from center of a circle to chord bisect the chord. So first we'll try to draw the diagram. So here circle is given, circle with center O is given and one chord AB is given. Now what you have to do? Perpendicular from the center of circle. You have to draw perpendicular from center of circle to chord. That means perpendicular to chord. A line we have to draw, that line L is perpendicular to chord. So that line L making the angle of 90 degree with this chord. So if we draw one perpendicular that passing through the center of circle, or perpendicular must be passed from the center of circle, and that perpendicular to chord will bisect the chord. Bisect the chord means this intersection point, suppose M is the midpoint of this AB. That means that point M bisect the chord. So this point M divides our line segment AB into two equal parts, AM and BM. That you have to prove. Clear students? Perpendicular L passing through center of circle, that perpendicular L to our chord. If we draw one perpendicular L to our chord which is passing through the center of circle, so that perpendicular will bisect the chord. It will make two equal division of our chord. In short, we have to prove this AM equal to MB, or this M is midpoint of AB. Done? So given. So here what we are given? Chord AB. AB is the chord of circle. AB is the chord of circle with center O. AB is the chord of the circle with center O. And to prove, and also we can say that our L is perpendicular to AB. This is given. And to prove this intersection point of L with AB, that means M is the midpoint of AB, or we can say AM equal to MB, that you have to prove. Done? So here let's start with our proof. We have to prove that perpendicular passing through the center of circle bisect the chord. So AB is the chord, and here line L is perpendicular to AB. Line L is perpendicular to AB, and line L intersect AB at point M. So now draw radii of circle. Draw radii OA and AB. So let's consider two radii. That means two radius of circle, OA and OB. These are the radii of same circle, so they are having the same length. Done? So now we'll consider two right angle triangles, OMA and OMB. So in triangle OMA and triangle OMB, two right angle triangles are there, OMA and OMB. So here in this triangle we can say that this angle OMA equal to OMB, because this L is perpendicular to AB, so measure of this angle is 90 degree. So these two angles are 90 degree. So here we can write measure of angle OMA equal to angle OMB. Reason is right angles 90 degree. Done. And this OA equal to OB. Second, OA equal to OB. Reason is radii of circle. एक ही सर्कल की दो रेडियस, so they are equal in length. Done. So right angle, hypotenuse and side, we can say that this OM equal to OM, which is common side. So here we can say that triangle OMA is congruent to triangle OMB by which rule? RHS rule. Right hand, hypotenuse and side. Right hand, that means 90 degree, hypotenuse on one side is common. So triangle OMA and OMB are congruent triangle, and therefore we can say that AM equal to MB. These corresponding sides, AM equal to MB by शिल्पा सेटी. क्या होता है? Corresponding parts of congruent triangle. These two sides are equal. So what is AM and BM? These are the parts of chord. So we can say that M is midpoint of chord AB. M is the midpoint of chord AB, and M is the point which lies on a line L. So therefore we can write perpendicular drawn from the center of the circle bisect the chord, because M is the midpoint of AB. Clear students? Pause the video and note it down.